Namaskara. In this session, we will continue our discussions on the closest pair problem. We were discussing about a divide and conquer algorithm. In the divide and conquer algorithm, we split the points into two halves, in two disjoint regions, and this is SL, this is SR, set of points on the left, set of points on the right. The closest pair distance delta L is found. The closest pair delta R is found. Delta is minimum of delta L and delta R. So we have defined a delta band around this line. This is the median which is splitting, and we found out that it is enough if we compute the distances between the points within this delta band, because points outside the delta band are going to define larger distances. There is no need to compute those distances, but within the delta band there may be several points, there may be order n points. So we want to further reduce the unwanted distance computation. In order to do the unwanted distance computation within the delta band, intuitively let us take a point here and consider a point which is, see, this is delta distance. If a point is outside the delta square on the left, delta square on the right, if it is outside, it is going to define a distance which is larger than delta. I do not want to compute any point distance that will give a larger than delta distance, unnecessary. So I found out that the first thing that we have observed is there is no need to compute the distance between a point P and a point Q that is outside the delta cross 2 delta box defined by P. So what is this delta cross 2 delta box? This is P, this is the delta cross 2 delta box. The delta cross 2 delta box defined by P is, it will have P on the upper edge of the rectangle, okay, and the points within this. It is enough if you compute the distances between the point. Anything that is outside, it is not necessary. This is very interesting. That is because you are going to have a maximum of 4 points on the left, 4 points on the right. P being a point we are considering, other than P there is going to be at most 7 points. So this means this box has got less than or equal to 7 points other than Therefore, if I know which are all the points within this box, so first I will define a delta cross 2 delta box for P and then figure out what are all the points within that and compute only those distances. And this means I have to compute only 7 distance computation per point in B. So, even if B has got order n points, this is going to be order n, because per point I am computing only 7 distances. So, B can have any number of points, B can have order n points, does not matter. For each point only 7 maximum, 7 distance computation. So, I will solve the computation of delta C, in order n time. This is a significant improvement. Therefore, I have to figure out what points we have in delta cross 2 delta box. Okay. So, B is a collection of points. For every point I have to figure out these 7 points. Which 7 points are within that delta box? Once I do that, I compute only those 7 distance computation, maximum 7 distance computation. But figuring out which 7 points in B are in the delta cross 2 delta box may take order n time, okay, because there are several points, which one is in that and which one is not in that. If you try to do in a naive way, it may take order n time. So, for each point anyway you will be spending order n time, again it becomes n square. Therefore, there must be a easy way to determine which 7 points may be in the delta cross 2 delta box. Okay. So, for every P, in the delta band, define delta cross 2 delta box, and we need to figure out which points of B are in this. I know that this has got less than or equal to 7 points. For every P there is a box, and in any box you can have only 7 points other than P. Which 7 points? So, in order to do that, we are going to sort the points in B in descending order of y coordinate values. First, to sort, consider the points in that order. So, now you can imagine that the points are available in the descending order of y values. Now, the sorted sequence. So, consider any point. The next point is below that. The next point is further below that. The next point is again further below that. In this way it will keep going down, and you cannot have more than 7 points anyway, not more than 7 points, because if you start from P, keep going down and down, all right, you will go far away. After, even you may have probably the 7 points, definitely the 8th point is not going to be in that box. Therefore, in this sequence you need not go more than 7 consecutive points, right. From P you do not have to, now because all the points are available in the sorted order, I know which 7 points I have to compute the distance with. Therefore, let B equal to B1, B2, Bk be the k points in the delta band in decreasing order of y coordinate values. then all you have to do is the following. For I going from 1 to k minus 7, okay, for j equal to I plus 1 to I plus 7, compute distance between B I B j. So, B I, this is B I, then B I plus 1, B I plus 7. These 7, compute this distance only between B I and B I plus 7. The 8th point will be further down and it will be way further down. It will not be within that delta cross 2 delta box. In fact, even some of them may not be there, but we do not have to do any test. We have a guarantee that you do not have more than 7 points. Therefore, per point you are doing only 7 distance computation. Okay. So, this has complexity order n. You compute the distance and then update delta c. Update delta c. Delta c is initially some distance, and delta c can be infinity. Delta c can be infinity to begin with. Then compute a distance and update delta c. If you find a closer pair, update it. This is going to compute all the distances in the delta band, all the necessary distances in delta band, and delta c is found. So, this is order n even if B is order n, because per point you are computing only 7 distance computation. So, even if B is order n, delta c computation is order n. Okay. Therefore, we have now efficiency brought into the divide and conquer algorithm by looking into the way in which we can reduce the combining cost. Okay. So, now I will give the pseudocode summarizing the discussions. So, closest pair of P, it is going to output the minimum distance delta. Okay. Step 1, find median x m for the set x1, x2, etc. xn. So, here P is the point set P1 to Pn, and Pi is xi, yi. Find the median. Define SL is set of all points Pi such that xi is less than or equal to xm. SR is set of all points such that its value is greater than xm. So, by one scan, right, find out which one should go into SL, which one should go into SR. So, this can be done in order n time. Input can be split into 2 disjoint set and they are in disjoint regions. That is important. Closest pair SL, this let it output delta L. Closest pair SR, SL, this is SR, let it output delta R. Recursive calls are done. Then let delta equal to minimum of delta L, delta R. Now let B is a point in the delta set. So set of all point Pi such that x m minus delta less than or equal to xi is less than or equal to xm plus delta. So all the points in the delta band are collected. Now the next step is sort the points in B in decreasing order of y coordinate values. Let the sorted sequence be equal to B1, B2, etc. Bk. Okay. So this step, and after this step let us count the step number. This is 6. So the next one is 7. Sorting is 7. Then 8th step is compute delta C. This is the following: for I equals 1 to you can write 1 to k, all right, there is no problem. Whatever is not defined, ignore that. For I equal to 1 to k, for j equal to I plus 1 to I plus 7, okay, for j equal to compute distance between Bi and Bj and update delta C. So this computes step 8, delta equal to minimum of delta L, delta R and delta C. Okay, return delta. The complexity is, we can see, finding the median is order n, there are n points, median algorithm, okay, standard median algorithm. Splitting, you have to compare every point x coordinate with xm, put in SL or SR, order n. This is T n by 2 recursive call, this is T n by 2 and this is order 1, you are finding the minimum. And now this is order n, each point you compare with xm minus delta and xm plus delta x coordinate value. If it is in the range, put in B, otherwise ignore. So you can build B in order n time, sort order n log n, and this is order n, we have seen, for each point 7 distance computation, and this is order 1. So everything is order n, there is one n log n step. Therefore the recurrence equation is T of n is 2 times T of n by 2 plus O n log n. This means it is O n log square n. We are going to see in our next session how we can reduce this further to O n log n, okay, by working on an idea of more for less. We will reduce it further. It is the same divide and conquer algorithm. our plan and action will be very similar to whatever we have done here, but we are going to throw a little bit more on the demand and reduce the complexity to O n log n. The magical step and the core idea behind that we will discuss in our next session. Thank you.